Hello everybody. In this video we will look at the reaction of acyl chloride, which is carboxylic acid derivative, with a nucleophile such as alcohol. So we know that the carbonyl carbon is delta positive and oxygen is our delta negative, and this is a nucleophile, to be precise, which is serve as a nucleophile. Oxygen is our nucleophile. Okay, oxygen with lone pairs. And the carbon atom right here is delta positive, so that is a electrophile. That means it loves electrons. So who has electron? It turns out oxygen has electron. So it would come and attack on this carbonyl carbon. And then to maintain the octet, maintain 4 bonds around carbon atom, we will push one of the two bonds, one of the two bonds right there, the pi bonds, will be pushed up towards oxygens. So we will end up making CH3CO minus. Why it's O minus, we know. So oxygen has 3 lone pairs, it's got extra electrons, and by shortcuts, when oxygen has 1 bond, it's gonna be negative. When oxygen has 2 bonds, like here, it's gonna be neutral. When oxygen has 3 bonds, like here on the bottom, that we will draw in a second, O, CH3, and H. So when oxygen has 3 bonds, it should have a positive charge. Okay, so that's our shortcuts. Oh, I forgot to write chlorine here. All right, there we go. Okay, so now you created a tetrahedral intermediate. So this is called as tetrahedral intermediate because the central carbon atom here is sp3 hybridized, and we know that sp3 hybridized are tetrahedral in general, right? Oh, come on, I wrote tetrahedral intermediate. All right, so next thing what we will do is in our reactions, if we're gonna deprotonate this. So every time you see a positive charge on oxygens, your goal should be to neutralize somehow. We can neutralize it if we bring back these two electrons back to oxygens. Okay, so we can have CH3 CH3CO minus Cl and O CH3. All right, so now we have our BH plus right here. So base, this means anything that could abstract a proton will abstract the proton and will make it neutralize it. And then at the end, what's going to happen is, because chlorine is a good leaving group, we have established in our previous video that chlorine is a good leaving group. So you will end up making CH3CO, OCH3, Cl minus. That's basically gonna be the counter ion for whatever you had here, B plus H. B means anything that could have abstracted proton. It could have been HCl or your water or whatever, or your alcohol, whatever you are doing your reactions with. Okay, so I will just write Cl minus. Okay, so that's our product. So again, we don't need any catalyst for this reactions because the acyl chloride is reactive on its own. We could use a simple nucleophile such as CH3OH. Okay. We could do the same thing here. If we can react this with ammonia. Okay, so nitrogen is lone pair, and then you can, this is called aminolysis. It doesn't have, it's ammonia, or you can do an amine reactions. Maybe let's just do an amine. So let's say nitrogen has 2 and one side we got CH3 NH2. So this would come attack here. Nitrogen has lone pairs, it'll go there. So here we will end up making CH3CO minus Cl, and then on the bottom we got NH CH3, and every time you have 4 bonds of nitrogens, that's going to be positive charge. So 4 bonds of nitrogen positive, 2 negative, 3 is neutral. Nitrogen should have 3 bonds. So you can see here nitrogen has 3 bonds. One side is alkyl group, another side we got 2 hydrogens, so total 3 bonds. So this is delta positive, delta negative. All right, so now we have a situations here. So your next goal is to neutralize it. So we have something would abstract a proton to, so 2 electron would go back to nitrogens. Now what that something would be here is anything that could abstract a proton. So what is the most basic thing that you have in your reactions? We know that nitrogens, the amines are extremely basic. So these amines are extremely basic. Every time they see a proton, they're going to immediately abstract a proton. They are highly basic. So one of the amine is going to go and attack that hydrogens. So let's say if you have 100 of these and 100 of these, you cannot drive the reaction to the completions because 50 of these would be utilized to abstract the protons. So if you have, oh no, I deleted. So let's say if you have 100 of these, then 50 of this would be utilized here. Another 50 of these would be utilized here to abstract a proton. So your product, how many product you will be making, you can only make 50. So in order to drive the reaction to completions, you need at least twice as much. So you need at least 2x or x's. So you will see in your questions, it will be written like this, twice as much. What would be the product? So one of these would need at least 2 of these to react, 2 or x's. Okay, so again, this reaction is called aminolysis. So CH3, CO minus, Cl, and on the bottom we got NCH3H. So nitrogen has 3 bonds, so it's good. It's neutral. Okay, so now our group is, this group's gonna kicked out. So why that group again? You cannot kick this one out. This one will never get kicked out. So you have a choice between these and this. How do we figure out? Again, same way. Look at what's the leaving group here. The leaving group on the case 1 is Cl minus versus the other one would be CH3 NH minus. Okay, so first thing you look at their conjugate acid, which is HCl. Here it's gonna be CH3 NH2. Okay, and next thing you're gonna look at their pKa values. HCl is -7. Here it's gonna be somewhere close to 35 to 45. I don't remember exactly. Let's say it's idea is very basic. So this one is the most acidic. So this one is more acidic. If something is more acidic, the corresponding base would be a weaker base. Weaker base means better leaving group. All right, so we got our product CH3CO NCH3 NCH3H, and what is the byproduct was Cl minus, and then we already had CH3 and H3 plus. So that's basically a ammonium chloride. So you have a counter ion, positive and negative. All right, so let's stop this video here.